Kia ora, hello, and welcome from Aotearoa, New Zealand, if you're in a different part of the world. Thanks also for your time and allowing us to reveal where we're at with DysCalculator and show you some of the features that are now embedded into DysCalculator. So this is our team, a small team. Initially, myself and Keith have worked away for about 10 or 12 years now with DysCalculator or a similar type of tool, being backwards in our thinking, but came to the fore every once in a while. And it was not until the last few months where, through a series of casual almost conversations, this wee team got together, and we've now accelerated hugely in the development of DysCalculator to a point where we'll have the tool. We have the tool now that Philip will shortly show you some of the features and a demonstration of DysCalculator. Also, Michael will then take over at the end and just a little bit of where to and what our plans and aspirations are for DysCalculator. So a long time ago, it was probably about 10 years ago, when I first approached a major international producer of calculators and began talking with them over a period of about 18 months about how the calculator was laid out and what the options were about altering that layout to better suit dyscalculic, high maths anxiety, and other neurodiverse learners. And that had come about because of my work with this in this area, was particularly with dyscalculia and high maths anxiety. And one of the things I'd done from years prior to that was worked with calculators where the learner would come to me in my role with a problem in negotiating some number problems. But the learner would have a calculator but struggle to engage with it and struggle to get information in and out of the calculator. So I spent many times with Twink and with tweezers, basically pulling calculators apart and altering them so they were individual to that learner. And that proved very successful. But in doing that, there was a whole lot of similarities or sameness about the differences. And it started to lead me towards thinking there's a better way to do this on calculators. And although I'm not saying that DysCalculator is the entire solution, it's one tool, part of a solution, I believe, to make numbers more accessible for our neurodiverse population. So back in about the 1920s, the term dyscalculia first appeared in print. And the term dyscalculia and maths anxiety started to become more and more common and understood. And in fact, now we've got reasonably good at recognizing dyscalculia. In about 100 years that's followed, we've got to that point. However, we still have very few tools and resources to assist dyscalculics and high maths anxiety operators with day-to-day number challenges. And the tool we've made here, DysCalculator, we think changes that. Just a few symptoms here of dyscalculia, and you'll probably notice that there's a high comorbidity here with other neurodiversities. But I'd just like to show you a couple of symptoms and talk about how they focused our features on DysCalculator. So for example, the low confidence in answers, problems transferring info. So something like 2 + 3 = 5 is okay. However, to transfer that data to 3 + 2 also equaling 5, or even to a further extreme of 5 - 3 = 2, is a step too far often for dyscalculics. Issues counting forwards and backwards on number lines proves a real problem or a real challenge, and hard to count in 2s, 3s or above. So counting up 2, 4, 6, 8 or 3, 6, 9, 12, very difficult. And as an example of that, if I gave you a number, maybe a number like, let's say 48, and asked you to count backwards in 4s, then I suggest that it would take a little bit of your working memory to be able to do that, and it would take a little while to do that. So as an example, imagine that was the same issue for you counting from 1 to 10, which I think is something similar to how dyscalculia affects the ability to engage with numbers. So those are the type of examples there. Hard to remember number facts, so I can remember something. And this has been a particular issue in schools and learning institutes, where the teacher can go over a topic and find that the next day the student is back with no memory at all of what that topic was about, and certainly no memory of the number facts and figures that came from that lesson. So continually relearning for the dyscalculic, relearning basic number facts basically daily. chronological or sequential number problems, like addition, subtraction, place value problems. In the real world, how do we get from millimeters to centimeters to meters to kilometers, that type of thing. Issues with speed, time, problems with money, with change from money and payments and receiving change, although that's not such a big deal now with cashless society. It certainly is a problem prior to that. And again, with value, what is a good buy? What is not a good buy? Very, very difficult for dyscalculics to be able to distinguish between those. And again, spatial issues, left, right, time, hours, minutes, and seconds. So if we look at all of those symptoms we've got there, that was one of our challenges in designing DysCalculator. The number line, for example, very, very important that DysCalculator has a number line, and you will see when Philip demonstrates that. Also, it was imperative for us to have DysCalculator be able to do time calculations. These time calculations are one of the more common global symptoms or universal symptoms of dyscalculia, with the challenges of navigating time. So exceptionally important for us to include that in DysCalculator. And we're often asked, is there a line between maths anxiety and dyscalculia then? And the answer is yes, but it is extremely vague, it's extremely difficult to see, and it's extremely hard to actually negotiate your way through. To me, what separates those two groups is that the dyscalculic population will not respond to the same interventions that a maths anxiety population will. So maths anxiety will respond to interventions where you won't get the response from a dyscalculic. So what I'm saying there is it's often very, very difficult to know that difference until you begin working with a particular person. I believe the picture looks something like this, where maths anxiety is seen as the huge issue, and dyscalculia hides in that circle of maths anxiety. And sadly, I think a lot of dyscalculics have lived their lives unaware that such a thing even exists as dyscalculia, and they've in fact lived their lives thinking they were just slow, unable to work with numbers, and numbers weren't their scene, and were labelled often as being quite slow, thick and stupid, for want of a better term. I'm sorry if I offend anybody by using those terms, but if you talk to a dyscalculic, they will echo those sort of comments. I was saying about time. Time is particularly important to a dyscalculic, and this is an example of a dyscalculic learner that I worked with probably 20 or so years ago. And the learner was doing an administration program and was working on timetabling events for an office. And the learner was having such difficulty being able to do this. I got the learner to draw a clock on the whiteboard and show me what she understood as the clock. Now, for this learner, the 4 was the strategically important number on the clock. If the small hand was pointing towards the 4 and the big hand was around there somewhere, people would say that was 20 past 4. So in her mind, 20 past 4 was 24, being 4 plus another 20. So that then must be 24 hours of day, because people say, oh, there's 24 hours of day. So if that's the case, the opposite side of the clock, between 8 and 12, must also be 24 hours of night. And the time down underneath there, from the 4 to the 8, she didn't understand, so she basically ignored. Now, if you can throw that into your day-to-day life, that makes things hugely challenging. We often used to giggle and joke about basic home care of cooking, for example. And I get a call saying, hey, I've just put an item in the oven that needs to be in the oven for 25 minutes. What time do I take it back out again? And things like the stove needs to be set on 180. I have no 180 on the dial of my stove. How do I set it? That type of daily issue is prominent for dyscalculia. I'm sure you've probably seen some of these and heard some of these questions or possible solutions. Just teach them to use a calculator. That'll fix it. And I certainly fell into that trap early on, thinking I could simply teach a dyscalculic to use a calculator and the end of the problem. I quickly found that wasn't the case. And in fact, that needing to relearn all the time made that calculator fix an impossibility. Anyone can do math. We're aware now that there is a group that simply are so challenged they cannot do math. And that's the group that we really want to focus on with DysCalculator as well, our dyscalculic population. They just need to try harder. And I can suggest in my work with dyscalculia, it's very hard to find a student in a class trying harder than the dyscalculic to understand number problems. Just simply not the issue at all, or not the case at all. So my early work on calculators, as I was saying briefly before, was about modifying calculators individually for students. So I did a lot of work in cutting up keypads and altering keypads, and then went on to twinking out various signs and symbols on the calculator and relabeling them to what the learner wanted. And this becomes a key part also of dyscalculator, as you'll see shortly. So there was a lot of work in toying with what was currently available, but it didn't solve the whole problem until we could actually scrap the layout and start again. So over the years, I walked many corridors and blank alleyways trying to get support to build a dyscalculator, or build a calculator that was individualized or personalized to different operators. So it wasn't until very recently, when just casual conversation with Michael brought Philip on board, and meteoric advance after that point in being able to generate dyscalculator. So with that, I'd like to hand over to Philip and get Philip to show us around dyscalculator.
Yeah, thanks for that, Gary. So here's a dyscalculator as we have it right now. And we're really trying to make this calculator a personal tool, a personal calculator for just you, just the user. And so what we've done is we've got this greeting at the top. And because it's my calculator, I can go and tap and hold this hello friend, and I can type in my own name here. So that now says hello Philip, and you can change it to be your own name. And then that indicates to you that it is your calculator. And that's what Gary was talking about, really making this tool talk your language, so that putting information into the calculator and getting information out of the calculator is aligned with how you think about how that works. So the first thing that you'll see is that it is a calculator. There are lots of buttons on it, but if you look a little bit more closely, you'll see that it's different to the calculator that you probably have on your desk or in your desk drawer. And the first thing that we have is a number line across the top here. So unlike a calculator where the keys are arranged in a matrix and the physical position of the key isn't related to the size of the number, here the keys increase in value from left to right. And then unlike your computer keyboard, the 0, which is smaller than the 1, is to the left of the 1 rather than at the end past the 9. Continuing on that first row, we've also got the decimal point at the end, because normally when you write a number, it'll be a number followed by the point. And similarly, the negative sign, because when you write a negative number, the negative sign goes in front of it. We've got a number of settings here that we can go have a look at if you tap the settings button. And if I'll just walk through these down the left-hand side, one of the key things that we know about is language can be a barrier to math. So if you're reading a word problem, for example, and it's not in a language that you are fluent in, then the language can be its own barrier. So we have a few different languages that we're working on. These are just the first items off the top of the block, but our expectation is to build more languages as time goes on. As Gary mentioned, there's often a comorbidity between dyscalculia or maths anxiety with other neurodiversities. And one of the things that we've included here is that we can add these Irlen colors, which shade the entire display to reduce the contrast between the black text and the white background. And we've got a few different keyboard options that I can talk about at the end. And we've got a setting where you can change the number of decimal places that are shown to 2, which you might use, for example, for money calculations, where you have 2 decimal points after the dollar sign, or 3 decimal places, which might be used in engineering circles, where you might have 3 dp precision in your calculations. We've included the accessibility font, and I'll just turn that on and show you what that looks like. So this is the Open Dyslexic font, which has the characteristic shape of the heavy baseline of the characters to stop them jumping around on the page. And that's been shown to be really effective for users with dyslexia. And then that'll help, so that'll help with that. So here's my calculator. And it's time to do some math. So what I'm going to do is my favorite formula, which is 1 + 2 × 3. So I'll type in 1 + 2 × 3. And a couple of things along the way there. So I said plus, but this key says add. And so the same way that I could make the greeting refer to me, I can tap and hold this key and change its label from add to plus. And instead of multiply, I can tap and hold that to say times, or it might be lots of, or it might be sets. So we can label it to anything that uses the same words that you understand. And you can see here that it shows me the answer before pressing the equals key. And depending on the calculator that you use, you'll get either the value 7, as here, or you might get the value of 9. And the reason for this is really related to the order of operations. So it's important to us when we build this calculator that it follows the agreed on rules of mathematics, which you might know as BODMAS or PEMDAS or other various abbreviations. And it's essentially that brackets go before exponents, which go before multiplication and division, which goes before addition and subtraction. And if you tap on this formula here, it will show you the working steps that it's taken to arrive at that final answer. So because multiplication has a higher precedence, the 2 × 3 is evaluated first to give 6, and then the addition is a lower precedence, so it follows to make 7. And your desktop calculator might give you a number of 9 because it would go simply left to right and go 1 + 2 makes 3, and then multiply that by 3 to give 9. So this might be a good time to show you the text-to-speech feature. So if I go back into settings and turn on read keys aloud, when I now type in this equation again, it'll read out the keys as I type them in, including the labels that I've given it here. So I'll just do that now.
Clear. 1 + 2 × 3 = 7.
And so we've put text-to-speech into various different features of the calculator, but I won't show them all right now. I'll go turn that off for now. So a couple of more advanced calculations maybe that I'd like to show you. One of the ones that Gary talked about is time. And so we've put a bit of effort into how we represent time here. And so we might motivate this by saying that you have to repeat a procedure every 25 minutes, perhaps, and you might start at 9 o'clock at night. So how would you do that in DysCalculator? So you would start by typing in 9 and type in this AM, PM. And so that takes me to 9 AM, and I'll tap that same key again to get 9 PM. And what you can see is we've got these pictograms that will be a visual guide to what the value means, just to help the user understand what those numbers represent. So let's say I have to do something every 25 minutes after 9 PM. So I now go plus 25 minutes. And so that now takes me to 9:25. But let's say that I have to do something every 25 minutes, let's say 7 times. So I will then go 25 minutes times 7. Let me try that again. Let's say I have to do something every 25 minutes 9 times. So I would go 25 minutes times 9. And you can see that this now says 12:45 AM with the clock pictogram, and it says plus 1 day because this refers to 12:45 AM tomorrow morning. Another time calculation that's quite common is a time difference. So if you wanted to find out the difference between 2:30 afternoon, if you wanted to find the time difference between 2:30 in the afternoon and 11:45 in the morning, you could type it in as 2 PM. So I tapped the AM, PM button twice, and then 45 minutes. So that makes it 2:45 PM. And then I can subtract 11:30 AM. And then that gives me a time difference of 3 hours and 15 minutes, and so on. There's various different ways that you can use clocks and times and time differences, and we've tried to put in as many of those as make sense in here. Another category of maths problems that you might often encounter are to do with fractions. So this might be if you're baking a cake and the recipe is talking about cups and spoons in fractions. DysCalculator does these with the fraction button. So if I were to type in 1 fraction, I would go 1 fraction 3 to get a 1/3 fraction. And we've put a pictogram on fractions as well to show that 1/3 of this is shaded and the other part isn't. And now I can do the same kind of maths as before. I can add different fractions together. So I might add 1/3 and 1/2. And then that will show me the 5/6 shaded. And then I can also multiply those fractions together. So for example, 1/3 and 1/2 of 7 gives me 3 and 5/6, as you can see here. So the fractional part is still shown in this pictogram with the shading, and the whole number, the 3, is collapsed down into a little pile of holes with the number 3 on the top. And as we had before, the working view is the same. I can still tap on this formula to reveal how the final result was arrived at. Another feature that we've put into DysCalculator is called solving for the unknown. So this is often if you have 1 + what = 10, things like that. And you can make fairly complicated equations and have DysCalculator solve it for you. So if I go back to my original equation, let's say I didn't know what the middle number was. So I might go 1 plus, and then I do the solve key here, which is on Shift equals. So 1 + what times 3 equals 7. And so when I complete the right-hand side of this equation, DysCalculator works out what value must have been on the left-hand side and fills that in for us. And you can do equations on both sides of the equal sign. So I might do 7 + 3, and then that would be 1 + 3 times 3 equals 7 + 3. And it also shows me at the same time what those two sides equal, which is 10. And here again, I can tap the equation to see the derivation that it took, how it solved the right-hand side first and then inverted the left to get to the unknown value. Another feature that comes up often in daily life is to work out percentages and adding percentages. The way that you can do that in DysCalculator, there's a couple of different ways that you can do that. But let's say you're trying to work out your GST content. You're in New Zealand and you're working out your GST content on a $200 purchase. So I can type in 200, which represents my $200, and we have a special button for tax, which is this one here. So in New Zealand, GST, goods and services tax, is 15%. And DysCalculator will work out what the total amount is after tax by adding in that tax bracket. But let's say you're in a different country. If you're in Australia, say, the GST tax, or the tax rate, is only 10%. So I can go into the settings here and change the tax rate that it's calculating from 15 to 10. And then it will do the same calculation, but now use the different tax rate for that amount. Another example of how you might use this is if you're at a restaurant with friends in the United States, perhaps, and you have to work out 18% tax as a tip. So let's say your meal cost $54. You can also type in the tax amount, or the percentage amount rather, directly. So I can go 54 and then add 18%, say, and then that gives me the total amount by adding the 18% to the 54. So just one last thing that I glossed over in the settings at the beginning are the different keyboard layouts. And I'd like to show you just one of these mini ones. It's called Simplified. And we've had some good feedback about this. And what it does is change the keyboard layout to minimalist, change the keyboard layout to the least number of keys that we can think of that are useful for day-to-day calculations. So this might be useful for school students that don't need the advanced calculations, or maybe even for day-to-day where you only really need the 4 primary algebraic operators. And the thinking here is that it reduces that cognitive load of having so many keys at the beginning when you open up the calculator. Now, all of the functions are still there. It doesn't change the functionality or the power of the calculator. It gets a little bit messy when I press the Shift key and all of the keys show up. But it's just one of the things that, again, we're trying to make the calculator fit your needs or the learner's needs and reduce that cognitive load so they can focus on just the mathematics that need to be done. Thank you.
And if you like what you've seen, why don't you give the app a go? Visit us at www.dyscalculator.app. Our web app is available for free, and we will soon have an Android app available also. To stay up to date with any new developments, follow us on our social media channels. You can find the links and further information in the description below. We would love to hear from you and get your feedback, and you can contact us at info@dyscalculator.app. On behalf of Gary, Philip, Keitha and myself, a big thank you for checking in. Tschüss, Kakite, and goodbye.